Thank you for the introduction, Phil. So we're going to talk about the future of communications and enablement of digital transformation. So we talked about digital transformation, but we haven't really talked that much around the underlying infrastructure to accomplish that. And we're going to talk specifically about IoT as well. And that's where we're going to kick it off. So, so why don't we start, actually before we start talking about that, maybe a couple of seconds on your background, what kind of projects, clients you're talking to right now. Sylvian, I'll start with you.
Yeah, I'm an IoT architect consultant at CISCO. So I work mainly with smart grid projects, power grid project with utilities, energy sector as well. I deal also with projects involving smart cities, transportation. So anything where there's a heavy involvement of IoT, it's exploding right now. So lots of project going on, and this is mainly what I deal with. I've got a switching routing background in terms of networking plus a security background, but now I'm using up and leveraging all of this to apply this to IoT, whereby you have these kind of technologies, but they're applied differently, and there's different needs as well. So it's a fascinating world, but different. Needs to be addressed in its own way.
Excellent. Dan?
Well, good afternoon. Hello everyone. I'm with TELUS. I'm based in Toronto. The team I lead looks after the financial services market here in Eastern Canada. So Tier 1, Tier 2 insurance and the banks, both teams in both Montreal and Toronto. Prior to that, I looked after the public sector in Ontario, so I can bring some of that perspective to today's discussion. And prior to that, I did business and technology consulting. So for today, what I hope to be able to talk about, or at least discuss, is from my perspective, working with customers, where they're at in terms of adoption, what are their business requirements, business drivers around some of the solutions we're going to talk to. TELUS positions ourselves as helping customers accelerate the business transformation that is going on in various organizations and various companies through enabling IT technology. So that's literally our perspective, and hope to share some of that today with you.
Excellent, thank you. So why don't we start there, and maybe Dan, you can continue on in terms of IoT. What kind of conversations are you having with Canadian companies right now around IoT?
Yeah, I think I see it as and we're going to hear a lot about the technology. I think there's another presentation following this on IoT, what the future. I think we've gone through our first wave of IoT in the sense that obvious applications in manufacturing, process, logistics, financial services in terms of insurance, in terms of in the user group of insurance, in terms of those things have been done. They've relied on the networks that were available to them to be able to be enabled. We see a lot of companies where if it makes sense to, that they need to monitor devices that are far-flung and remote, we've done a lot of work around enabling that type of monitoring and data collection via our wireless network. So I think that seems where we're at. In terms of new other applications, I think it's a variation on the theme for now. But I think as we get into this discussion, we're going to see that some of the new technologies and new approaches are going to what I believe it was release a whole new wave of IoT types of applications that'll drive different business outcomes, and so that's what we're seeing right now.
Sylvian, in terms of what you're talking to clients about?
Well, when it comes down to IoT, one of the first thing that I can think of, if there's one word I can think of, is disruption. IoT is disrupting many things in our society. It modifies and changes the way we work, the way we live, the way we entertain ourselves. And we see that in our personal lives, but also at the office or in the industrial environment. Right now, you can see, and everybody's seen in the past couple of years, Uber disrupting the taxi industry. We've seen Amazon disrupting the business consumption model. We've seen AWS and Azure disrupting and bringing new ways of consuming data center cloud services. So all these things brings in lots of IoT in many cases. And IoT in, let's say, a substation or in the manufacturing environment to do predictive failure analysis, or in the transportation, analyzing telemetry systems. You can think of so many different things where organizations are interested in collecting data in order to process it and eventually create intelligent information they can act upon. IoT is not an end by itself. It is simply a mean of collecting raw data and creating intelligent, useful, strategic information that will help you eventually in your business being more competitive, more strategic. If you are an organization in the manufacturing industry, transportation, name it, if you are not considering that, or at least thinking about this next wave of connecting yourself and collecting that raw data and creating intelligent information out of IoT, maybe your competitor is. At some point, you might vanish or disappear if you don't adapt. So, and all that information we're collecting, we need to do something with it. We need to have ways of being able to absorb it. And this is one thing that we're going to certainly talk about in this discussion.
So maybe you were talking about manufacturing, those kind of settings, and I had a conversation with, I forget the gentleman's name, from Shell Canada yesterday, and we were talking about OT, IT. Obviously, they have different needs. So from your point of view, Sylvian, how do you see IoT differing within IT versus OT? How does that connect?
Well, not the same purpose. IT, everybody knows what IT is. There's an IT department in every organization, and we know what that is. Yes, there are IoT more and more present in the IT side of the house, but I would say that even more so on the OT side. OT stands for Operation Technology. This is the more industrial and more production environment of your organization. For example, it could be the manufacturing production line in a factory. It could be all the IEDs and the substation component for a power grid. It could be in a vehicle, everything that collects telemetry from the CAN bus. So these sensors, you can realize very quickly that in an OT environment, you will have a lot of them, and you will need to manage them. You will be collecting huge amount of data at some point, and you have to make some sense out of that data. Just to give you an example, an oil rig can generate 1 terabyte of data per day of raw data, based on all these sensors that they need to have in order to have that visibility and to do proper monitoring, in order to be even more precise, in order to do predictive analysis on potential failures. A 30-minute flight on a plane can generate 10 terabytes of data. How do you deal with that? How can you consume that data and make some sense out of it? Very often when we collect that data, we send it back to the data center. That's the model that we've seen on the IT world. There is no way that you're going to be sending 10 terabytes of data from an airplane down to earth in the data center for computing and processing and come back with an analysis of a potential failure on a motor. There is no way. So you need to have new ways of dealing with data like that. Huge amount, what we so-called big data. And that answer lies into different architecture we call brokers or fog computing. So these are ways of doing pre-processing on the data close to the capture endpoint, very close to the sensors, and then process the data. Once you've processed it, then you send the end result to the data center to complete the processing. So that is something you're going to see more and more, whereby computation of such a huge amount of data will be done in the field more and more, within the router aggregation devices, within some switches. We know that now we can run APIs and all kinds of different software within containers and various devices. In the long run, that's an architecture that will need to be a lot more spread out, and that will need to be taken into consideration when you're thinking about OT and IoT.
Yeah, so maybe we'll come back to some of the security questions around IoT. But before we do that, I thought, so we're talking about data and the transmission of a lot of data here. So maybe that's a good segue, Dan. We talked earlier about 5G as a new standard. Can you help explain to us, there's a lot of talk about it, but what does it mean from an enterprise application perspective? What is it that the telco will provide, somebody like TELUS in the future, and what will allow us to do differently as we think about IoT?
Yeah, sure. It's an incredibly exciting opportunity that's just beginning to, we've talked about it, the protocol's been in place, there's been internal testing. We've recently published some initial testing where we proved in speeds up to just under a gigabit per second for 5G. So it really does kind of set the stage of what it's going to look like 3 to 5 years. So that one will turn into 10 over time. So what would it allow for? Well, right away, the speed of data transmission is going to increase and sort of support business cases and applications and use cases that just don't exist today because the speed isn't there. We're not able to actually do it. The latency is the other thing. The extremely low latency of 5G is going to allow real-time connections with devices that aren't possible today. So from an IoT perspective,
like autonomous driving is a good example.
That's right. So in terms of IoT, it's going to open up the world for that. In terms of how, as a service provider and as an integrator, how that's going to be deployed for enterprise customers, there's what we're going to end up seeing is the integration. If a wireless service is as fast as a fiber service at some point in time, then the distinction between wireless and wireline is going to go away. And we're going to see service offerings that are going to integrate those things together. So that in itself is interesting, but maybe not really that useful. But where we'll see it deployed, or a concrete example of that is for buildings that are being built today where there's still a discussion of do I need a wired network in the building? Can I actually have a building without wires simply by having a combination of Wi-Fi and 5G? And that's absolutely where we're going. So the service will actually be able to, in certain parts and certain applications for certain types of data, will be supported by Wi-Fi, and the rest of it will be 5G mobility. And that ability to drive it at speed and the low latency is going to change the way that we architect the way we use networks, and the difference between wireless and wireline will go away over time.
Yeah, that's any questions around that for our panelists around what that future network or the wireless network might look like?
Just a comment about the portability of it being cellular. I mean, it's great. There's no more landline provisioning, but the threat of losing it, like losing a SIM card. Someone could steal my fiber link to my office by simply picking up a router, or it being non-tethered. Something that we need to think about moving forward. You've solved the problem with provisioning wires over mountains, but then the ultra portability of it opens up another layer of security that we need to look at.
Yeah, and I think those SIMs that we treat as phones, if you think of them as the way we treat IoT SIMs now, so we have platforms that are able to, for fulfillment of those things, which have a different kind of security posture, just to your point. So that the security framework and the way we manage those devices will change over time. It won't be the same way that we carry phones around now. It won't be exactly like that. It'll be different. So to answer your question, it's an extremely good point. We won't treat it the same way once there's less of a differentiation between those two types of networks.
And just to add to that, from a healthcare spin, I put in physical lines in patients' homes for palliative care, and sometimes the provisioning of physical lines took longer than the actual service needed. So this type of service, to be able to turn it up and turn it down, provisioning is
Yeah, and I think Ray, the other thing is that we're, in terms of deploying IoT over wireless, there's also a motion that temporary SIMs, or SIMs that only have a certain lifetime in terms of where the economies of scale will allow you to deploy a SIM knowing it'll stop working at some point in time. But you'll be able to communicate with it using your smartphone for a period of time. So a gate, so a dumb access device, a physical access that you need for a period of time and that you expect to have to go change or you don't need it for anymore. So the temporary nature of deploying these types of things will also be available to people with this new type of technology.
So what's the timeline for some of these advances in terms of rolling that out?
It's in the 3 to 5 year. In terms of the 5G, that's about as much as my view into it. It's we're doing the testing now.
It requires new antennas and new cell engineering.
It is a huge.
It's quite different from what we've had so far.
Yeah, I agree. So that's that time frame.
Yeah.
Yeah.
So let's come back to what IoT then. So the architecture, Sylvian. What does a secure architecture for IoT look like? Where do you begin to think about that?
Very often we're tempted to apply the IT secure template to the OT world, and that's a mistake. The requirements are not the same. For instance, for those of you who might have a CISSP certification, many people might have seen the triad, the CIA triad, which is basically C stands for confidentiality, I for integrity, and A stands for availability. In the IT world, it goes in that order. Security has been at the top of priority when dealing with an IT network. And for years now, we've been building secure network with security top of mind. Whatever we did on the IT side, security was pervasive. You wouldn't build a network without thorough security in each and every aspect, whether it's wireless, whether it's connected wired, and so on. When it goes to the OT side of the house, it's quite different. It's no longer CIA. It's a AIC. So availability comes first before integrity and confidentiality. Why? Because there is nothing more important for a production line manager on a factory floor than having full availability of its production line. If you're building cars, if you're building tractors, or you're building toaster, whatever, you don't want that line to stop. So whatever security the IT people might bring in will be looked badly, because this might impede that availability. Right. It brings in a level of risk, potential risk, where because of security automated procedures, you might run into the risk of shutting down that production line. Same thing in a power grid, where electricity for a critical infrastructure utility is extremely important. You don't want these failures, these outages. So security has always been perceived as something that might bring in that risk and impede that availability that's so important for the OT people. We know nowadays that we can no longer, on the OT side, go by the say that security by obscurity. For a long time, the mentality was that we're not connected to the internet, we're not directly linked to the IT network, we are building closed doors with cameras, we're not going to be attacked, we're not going to be compromised. We know nowadays that it's not true anymore. Right. There are attacks going on in the OT world. It doesn't mean that it's because you're not directly connected to the internet, you're not going to be attacked. Sometimes the attack is going to come from the IT side. Attackers might stay weeks and months in the IT environment studying different ways of breaching some of your security procedure and go through straight to the OT side of the house. In other instances, it's mobile medias that might be used, that might be brought into the OT network. So there's so many different ways now. Therefore, OT needs to think about security. And what I'm saying here, the IT security template I was saying before cannot be applied directly to the OT. You need specialized, purpose-built security that's been designed to operate in an OT environment. You need firewalls and IPS capable of understanding industrial protocols like Modbus, like DNP3, like Profinet. The traditional firewall or IPS might not see a transmission that's been compromised on a Modbus protocol. An industrial IPS will.
Yeah.
Then after that, you have to take into account latency and timing and all these other components that are so important. And the very particular type of redundancy that we design into OT network. So at the end of the day, yes, OT is important because hackers are very much willing and capable now to attack OT networks. And we've seen it with Sony. We've seen it with the German smelters where the furnaces were attacked. We've seen it in Ukraine with substation being attacked. We've seen it, and I think that was day zero of the most famous OT attack with Stuxnet in Iran in 2010. That was an eye-opener, and that created some awareness all of a sudden that OT networks are being targeted. Not so much for the same reason, not so much to steal money or to put in ransoms, but to disturb or break down or create outages.
Shut down the environment, yeah.
So battlefield are shifting sometime from the field to the cyber world, and that's what we're going to see over time.
Wow. So security, we talked about that earlier today, super complicated, and in the OT, IoT side, it makes it even more complicated as you move down this path.
Different ways of applying the same principle.
Yeah.
We need to be secure on both IT and OT, but it has to be applied differently with an industrial template, if you will, or an IoT template.
Yeah.
Because we're connecting so many of these devices over time, it's going to be interesting.
Questions from the audience on security aspects of IoT? Around OT? Okay, sorry.
Yeah, do you have any recommendation on overall, broadly on architecture in terms of segmenting, how you segment, you would segment the Internet of Things, or even sub-segment it?
Oh yeah, for sure. I think right now, OT networks tend to be very flat. Segmentation was a word that was not too popular, was not very much known, and as long as it was working, don't break it, don't fix it. Nowadays, you cannot work that way. You need to bring in segmentation that we've been doing on the IT side. You need to bring that over in the OT side with identity systems capable of creating security zones in OT environment. Not all zones have the same level of sensitivity. There are zones that are more critical than others. There are sometimes timing issues you need to take into consideration. I'll give you an example. In a typical substation for a power utility, I use power utilities example quite often because I have a power grid and smart grid background, but you can realize that we could apply that to many other industries. But essentially, there's what we call an ESP zone, which is highly sensitive, which is driving teleprotection, for instance. That zone is separated from other zones driving and controlling PLCs and RTUs and PMUs and other intelligent electric devices. When it comes down to create these zones, you have to take into consideration, as I said, latency, accessibility, timing, because very often, and it would be the same in a manufacturing environment, you need to protect timing. Timing could be so important to a point that it can stop a production line if there's a loss of precision timing over the whole network. So when you're creating the zone, there's criteria like that, unusual criteria that you don't see so much on the IT side, but that you need to deal with when you're dealing with OT. And I would say that something that we didn't see all that much, but posture analysis and also credential. More and more, I think that these PLCs and RTUs and these endpoint devices, IoT endpoint devices, need to identify themselves when they connect to the network. It was way too easy to mock up a Siemens PLC, for instance, and hook it up to the network and then compromise a robot arms or a machine or a pump. Okay. So don't forget, these Modbus and Profinet and DNP3, all these protocols were built in the 70s and the 80s at a time where security was not a concern. It was not even thought of. So these protocols, typically industrial protocols, are vulnerable. Therefore, you need to add, the security layer and the security principle to them in order to make your network safe.
Very good. So, yeah. I guess we're all going to try the admin password on those old devices.
Yeah, believe it or not, when we do analysis, you see so many PLCs and automated endpoint device still with the default password.
So let's switch gears a little bit.
Let's start with that and correct that.
Yeah. So we're going to switch gears a little bit and talk about another technology that most of us have heard of, but we're going to go into a little bit more detail. So Dan, can you give us what does SD-WAN mean for Canadian companies, and how do you see it enabling sort of the cloud-first strategy, and what are the benefits and the cost of going down that path?
Sure. Yeah, it's a huge area. So I'll try to talk about it in terms of use cases. So software-defined networks is the ability to leverage commercially available internet access to locations. And control a device or a box at the end of that internet and mimic wide area networks. So the ability to, just as we describe that, the first use case there is simply speed of rollout. So if you have some sites, locations, and this applies to almost everyone here in the room in some way, if you have locations that aren't currently served by your MPLS network, but you need additional services, you need additional bandwidth, an SDN type approach may very well serve your purposes over time. So again, it's leveraging what's probably there already, which is business internet, and then controlling your box from a centralized location and driving out network services to that box from a data center and mimicking an MPLS network. So the use cases, again, is speed to rollout and cost is one of them. So if I think about my customers right now, enterprise financial services customers, we have a discussion going on with almost every one of them at some level. Some were actually moved into pilot phase, some were testing out devices, there's lab tests. Most people see this as, at a minimum, a way of extending the reach of their MPLS networks into areas that they don't have today by leveraging existing access services and then putting a box at the end to enhance their MPLS network. Once there, they can then make decisions around data. Where does the data ride? Can they access public internet from the SDN opposed to MPLS? Is there a cost, if they don't have to increase the size of their MPLS with this SDN? Those types of really fairly straightforward and obvious use cases. What's really exciting about all of that is then once that's established and in place, the ability to virtualize other network services and other cloud-based services to those endpoints and to those locations, that world really opens up. So if you think about it, if you're able to control a network device from a data center in that way, you can then begin to drive out cloud-based services out to that location in an extremely efficient, cost-effective, and low labor way of doing that. So think of spinning up a virtual firewall at a location, making changes from the security posture by leveraging this SDN infrastructure, right through to being able to take advantage of it to deliver unified communications, cloud-based unified communications at these locations. So that's where it begins to get really exciting. If we bring it back to this conference, So if we're, people like TELUS, we're here to accelerate your business transformation, but to bring to you managed services around enabling IT, this will be absolutely part of our future to put that in place to support customers.
Now, I believe TELUS is making this available, or you're launching this next
Yeah, this
winter?
is a version of this. It's network as a service is what we would call this right now. It's available in the mid-market as a standard service offering. That's been launched. There's a lot of activities from vendors, from traditional providers like ourselves. There's a ton of activity from non-traditional providers as well. I think we're a little further ahead, I believe. And it's available as a standard offering in the mid-market. And for my customers, it's absolutely a longer development cycle because of the enterprise nature of what they need. Right. But it's becoming part of their strategy as they look at how do I move, really define and implement their digital strategy, and how do they create the enabling technology to support this third platform that everyone wants to get to in terms of driving consistent customer experiences across all parts of their either their network or their channel.
Yeah. Questions from anybody around software-defined networking? No? All right. So let's switch gears a little bit to another topic that we touched on earlier today when we talked about process automation and the changing workplaces and what that's going to look like. So both your firms, TELUS and CISCO, have undergone a lot of cultural change in terms of what we call sort of the digital workplace environment. So, so we talked about digital transformation, IoT, SD-WAN, 5G. So let's talk about what that means physically. What does that physical transformation look like when it comes to how we work, how we attract and retain talent? So how does that work at TELUS? How do you attract a younger workforce?
Yeah, sure. I think this has been a 7 or 8 year journey for us. And the program we call is Work Styles. And the idea is to take a look at our workforce and make specific decisions around, depending on your role and location, you're either a resident worker in a building, you're a mobile worker moving around, or you're a home worker. And the concept is work in the right place with the right tools and be as efficient and tied into your team as possible. So those are sort of the overriding. So I'll just kind of cut right to the biggest lesson learned around that. When we started this process 8 years ago, there was certainly some objectives around financial objectives. It was HR objectives, it was real estate objectives, and then there was IT supporting all of that. And then if you take those 4 principles and you look at the work that we do with our other customers, the most successful work styles or the most successful approaches to those types of environments always have to include those 4 groups. So if you're either for yourselves or you're working with other partners, if those 4 groups aren't represented, then that is something that's certainly been proven to be the best practices. You need people and culture, you need the facilities, you need IT, and you need finance to bring all of that together. And the biggest lesson learned all of there, it's not surprisingly, is really not about the technology. You need the enabling technology to allow people to work securely from where they want to be. But it's really about the work and programs that go into the change management around allowing people to understand which of those 3 categories they fall into. The programs around supporting them if they're working from home, the programs around supporting line managers, around how to manage teams that are spread out across the country, some at home and some at work. So we've been doing this for about 8 years. It's had a massive change to our culture and to our physical footprint, and I think that leads into the way TELUS likes to portray itself as an environmentally conscious organization here in Canada. And then we've been able to take what we've learned and work with enterprises who are doing somewhat the same thing. It's either addressing some of the work-life balances around large enterprise to provide them those opportunities. But to your earlier point, Lars, it's also kind of bleeding into what type of work environment do the new generation of valuable, talented, younger people want to work in. They absolutely want the option of working remotely. They want to work where and when, but then when they are in a physical environment, the collaborative nature of the workspace is extremely important to attract, retain, and develop those people as well. So it's an extremely wide area of work that we do, and it all tends to drive certain specific business outcomes for customers.
Yeah. So Sylvian,
right.
inside Cisco, how did you experience that? And what would you say would be the key role that IT has to enable that digital workplace? What's been your experience?
Well, we develop technologies, so we kind of have to be in advance, and we test out what's coming within our own organization, so that first we can talk about it as an employee of Cisco, and also to see how a high-tech company with its own employees can deal with it. Is it going to work once it's hit the market? So you have to be open to changes. Changes sometimes will disrupt the way you work, the way you do your own thing on a day-to-day basis. But I think whenever you bring in new technology like that and new ways of doing things in order to attract and retain new people and be appealing to a whole new generations of younger engineers, for instance, coming into the company and stimulate their creativity, then you have to make sure that, a very important point, you have to tell them why you're doing it. You have to provide training, you have to provide lots of information, you have to provide a period of transition and making sure that nobody is left behind. And if something happened or something is not running smoothly, you have to make sure that there are ways of collecting feedbacks and treating and processing and addressing issues going on with new technologies. I'll give you an example. Telepresence is something that was an initiative that started in 2010 at Cisco. Video, HD, ambiophonic sound telepresence were meant to replace traveling. Cisco is saving a tremendous amount of money per year in traveling and hotel costs just by leveraging telepresence. Telepresence is spread out in all offices around the world, inducing agility, speed of execution, and getting ways of bringing in collaboration very quickly within the organization. But telepresence was a big shift, a big change in our environment. That involved training and a lot of information, a lot of availability for the support. But now this is something that's widely accepted, and we all see the difference in our life and how it's improving and enhancing the way we work within the organization. So I think that's the secret. You have to prepare these things and make sure that people understand it.
So we're out of time. We've had a wide-ranging discussion from IoT security, to 5G, software-defined networking, and sort of that digital workplace. Any final question for these gentlemen? Otherwise, we're going to call it there. All right. Thank you very much, gentlemen. Thank you.
Thank you.